A screw jack, also known as a worm screw jack, is a device used to convert rotational motion into a push-pull linear motion. It utilizes the property of a screw thread, providing a mechanical advantage, which means that it can be used to amplify force. The rotary movement can be supplied manually or thanks to the help of hydraulic or pneumatic motors, or thanks to electric motors like the induction motor. A worm screw is the essential feature of a screw jack. Here we can distinguish its main diameters, the thread elements, the pitch, which is the distance between two threads, and the thread angle. We can notice that this type of screw is a helical structure used to convert between rotational and linear movement or force. This is the pitch of the helix, while this is the tilt angle of the helix. In this section, we can clearly see the angle of the helix that determines the number of teeth of the screw, which are called cogs. Having a wide helix angle, the worm screw has a small number of cogs. It is called worm screw because its rotary motion has the sole purpose of being transmitted, like in every gear wheel. The worm screw meshes with a worm gear. These two elements are also called the worm screw and worm wheel. This arrangement can reduce rotational speed or transmit higher torque. Let us remember that the torque is the tendency of a force to cause or change the rotational motion of a body about its axis. Worm screw and gear arrangement has a high transmission ratio, which depends on the thread angle of the screw and the number of teeth of the worm gear. The screw transmits the rotary motion to the worm gear. Usually, this motion can only be transmitted from the screw to the worm gear and not the other way around. However, there are some arrangements where the screw and the worm gear have such a thread angle that allows the worm gear to drive the screw. The mechanical efficiency represents the measure of the effectiveness with which the mechanical components perform without losing energy, is inversely proportional to the efficiency. In fact, when the efficiency is less than 50%, and when the helix angle is equal to or less than the angle of friction, the mechanism will be irreversible and it can only be driven by the worm screw. The worm gear mechanism usually has low efficiency. That's because there are many contact areas. Plus, the sliding motion creates friction between the gears. For this reason, screw jacks have a high wear rate. To overcome this, special combinations of steel and bronze are used during the production process so that only the bronze parts of the worm gear mechanism can be. There are two types of screw jacks: the translating screw jack and the rotating screw jack. The translating screw jacks are the most commonly specified jacks. With this design, a driven worm acts on an internal worm gear, which in turn drives a lead screw. The lead screw translates through the body of the screw jack. For this reason, it is necessary to have free space on both sides of the jack. The end of the lead screw is fixed to the structure that needs to be moved linearly. In this way, the lead screw is prevented from rotating with the worm gear. In the rotating screw jacks instead, when the worm shaft is rotated, the lead screw rotates in the body of the screw jack at the same rate as the worm gear. When the lead screw is rotating, a nut translates through it, providing linear motion. In this case, it is necessary to have free space only on one side of the jack. The nut must be fixed to a structure that prevents it from rotating with the screw. A screw jack can be used individually or in a ScrewJack system configuration. Multiple screw jacks, in fact, can be linked together mechanically or electrically using couplings, drive shafts, gearboxes, and bevel gears, all driven by a single common motor. This allows the creation of real lifting systems designed to work in perfect unison, even in the presence of non-uniform distributed loads. Continuous improvement in motion control systems have led the ScrewJack to be a qualified device for the regulation of nano-precision motion control. Here, in fact, we can see that a combination of several ScrewJacks is necessary inside this automobile assembly plant during the engine installation. The engine represents a non-uniform distributed load, so it needs the right lifting system to be precisely positioned inside the car.